For the skill, I had my A value be 6, my B value be 8, my C value is 40, and my D value is 12. So using what the problem told me, I got one of my co-vertices to be at 6, 8, and I got one of my foci to be at 40, negative 12. So then the first thing that I had to do after that was find the center of my hyperbola. I did this by taking the x value of the co-vertex and the y value of the foci and using that as my center. I knew that this works because the co-vertex goes directly above and below the center, and the foci goes directly left and right of the center. And because of that, my center was at 6, negative 12. Next, I had to find my other co-vertex. In order to do this, I had to find the distance from the center to the co-vertex, sorry. I did this by subtracting my y value of my co-vertice from my y value of my center. I did 8 minus negative 12, which ended up resulting in 20. Since I knew that the co-vertice was 20 units up from my center, I also knew that there would be one 20 units down from my center. To get my second co-vertice, I subtracted 20 from negative 12 to get negative 32. Finally, since I knew for the other co-vertice, the x value would be the same as the center, and the other y value was negative 32, my other co-vertice was at 6, negative 32. Next, I had to find my other foci. I used the same method to find my other foci as I used to find my other co-vertice, but I just used the x values instead. I subtracted the x value of my foci from my x value of my center to get the distance from my center to the foci. I did 40 minus 6, which resulted in 34. I then subtracted 34 from the x value of my center to get my other foci to be at negative 28, negative 12. Next, using Pythagorean theorem, I was able to use the equation c squared minus b squared is equal to a squared. I can use this because the distance between the foci in the center squared and the distance between the foci and the co-vertice in the center squared was equal to the distance between the vertices squared. This ended up being 34 squared minus 20 squared is equal to square root of 756, which simplifies to 6 square root 21. Next, I knew that my vertices would have the same y value as my center, and you just have to add and subtract the value found in the previous step. And so after doing this, I got my vertices to be at 6 plus 6 square root 21, comma, negative 12, and 6 minus 6 square root 21, comma, negative 12. Finally, we can make the parametric equations by using secant as the x and tangent as the y. Since the hyperbola opens left and right, I multiply secant by 6 square root 21 because that is the distance between the center and the vertex. And then I added 6 to the function since the hyperbola is moved 6 units to the right. For the for the tangent portion, I multiply tangent by 20 since that is the distance from the center to the co-vertices. I then subtracted 12 from the function since that the hyperbola is moved 12 units down. So my final equations were x is equal to 6 square root 21 secant t plus 6, and y is equal to 20 tangent t minus 12.